Hello, today I'm going over template method pattern for CIS 476. Let's start with intent, which defines the skeleton of an algorithm in an operation differing some steps from the subclasses. It lets subclasses redesign some steps of an algorithm without changing the algorithm structures. What this means is we want base classes to have specific implementations of certain steps of a process. We want the process to happen in the right order. Imagine working in a pizza store. You need to follow a specific order. You would want to first take the order, process the payment, make the pizza, bake the pizza, cut the pizza, box the pizza, deliver the pizza. There is a template here to follow to make the final product. The algorithm here is how to make the pizza, but it is deferring some steps to subclasses because you can change some steps without changing the actual algorithm structure. Let's say we're going to cut the pizza into 12 pieces instead of 8, or we're going to half bake the pizza instead of fully baking it. So the deferred classes changes particular steps, but you haven't rewritten the actual algorithm structure. Next, motivation. One or more algorithm steps can be overwritten by subclasses to allow differing behaviors while ensuring that the overarching algorithm is still followed. So basically, template method pattern is used to create a group of subclasses that must execute a similar group of methods. Looking up the term template by itself gives us a preset format used as a starting point for specific application or order so that an item does not have to recreate a whole application each time it is made. Template method follows the same concept defining an algorithm in a base class using abstract operations that subclasses can rewrite to provide concrete behavior. Consider the diagram below. Consider it a framework that provides application and document classes. The application class is responsible for opening existing documents stored in an external format. The object named document represents the information in the file. Using this framework, the subclasses application and document can be used to suit any new application made to its specific requirements. For example, making a gaming application could turn the subclasses into game application and game document, while making a cooking application could change the subclasses into cooking application and cooking document. Now let's go over the applicability of the template method pattern. To implement the invariant parts of an algorithm once and leave it up to subclasses to implement the behavior that can vary. When factoring is performed and common behavior is identified among classes, an abstract base class containing all the common code in the template method should be created to avoid code duplication. Let's take a further look in the structure to see how this works. Looking at the structure, we already know that the template method defines a skeleton of an algorithm in an operation and differs some steps to subclasses. So, looking at this diagram, we know that the implementation of the template method is to call step 1, step 2, and to call step 3. Step 2 in here is what is called a hook method, which is a placeholder. It is declared in the base class and then defined in the derived classes. Frameworks like large-scale reuse infrastructures use template method a lot. All reusable code is defined in the framework's base classes, and then clients of the frameworks are free to define customizations by creating derived classes as needed. Kind of like how we used the framework's example before with the application and document object, which can be redefined if we're making a gaming application versus if we're making a cooking application. So, consequences template methods are fundamental techniques for code reuse. They are particularly important in class libraries because they are the means for factoring out common behavior in library classes. Template methods lead to an inverted control structure that sometimes is referred to as the Hollywood principle. Don't call us, we'll call you. This refers to how a parent class calls the operations of a subclass and not the other way around. Due to the above fact, a special care should be paid to the access modifiers. The template method should be implemented only in the base class, and primitive methods should be implemented in the subclasses. A particular case of the template method is represented by customization hooks. Known uses of template methods is that they are fundamental, that they can be found in almost every single abstract class. A rule of thumb to keep in mind is that template methods use inheritance to vary part of an algorithm. It also modifies the logic of an entire class. And factory methods is a specialization of template methods, believe it or not. Now, let's look at an example using code to understand template methods better. So let's say we want to make hoagie sandwiches. We can begin by making an abstract class to build any hoagie the customer orders. Our template method will be declared as final to keep subclasses from changing the algorithm structure. We do not want to have any input in making the sandwich because sandwiches are made differently depending on what the customer wants. However, we can put stuff we know is going to be part of every sandwich we make. Every sandwich, for example, needs to have cut buns, so that is a function we can include in the make sandwich. Then we can determine if the customer wants meat or not. If they do, then we add meat to the sandwich. We need to call this function so it is not lost outside the template method. Therefore, we can make an abstract term to implement the method. Then defining a boolean here that can be overwritten in case the customer decides that that he doesn't want meat, the method, or he wants meat, the method will remain true or false. And this makes it a hook operation. Now we can repeat this process over with anything that can be overwritten depending on the sandwich. For this example, let's include cheese, vegetables, and condiments. Then we can include wrapping the sandwich to all hoagies since we know that's going to be part of every sandwich we produce. We can include a method to define what cut, bun, and wrap hoagie are going to do as a final step to show exactly what these terms mean or what they produce. Now that we're done making the hoagie abstract class, let's say we get a customer that orders us to make an Italian hoagie. So first, we need to make the class and extend it to the abstract hoagie class. Then we need to add all the unimplemented methods in order to make the sandwich. This is optional, but I added strings to make the template easier to read by assigning what meats, vegetables, etc. the customer wants. Then we can add these inside the methods to get the output of the sandwich. And as you can see, it extends from the abstract hoagie class and we get an output of whatever Italian hoagie the customer wants. Another example here, let's say we got a customer that wants to order a veggie hoagie instead of a different sandwich. So it's just a repeat of what we did with the Italian hoagie, taking in the customer's order and using the abstract hoagie class in order to create the sandwich. The one viable difference here is that the Boolean expression is changed to false since the customer, let's say, is only vegetarian, so they don't want any meat or cheese on their sandwich. Now let's just go over a quick checklist or summary recap of what we did. So first, we examine the algorithm and decide which steps are standard and which steps are special to each of the current classes. And then we define a new object base class to host the don't call us, we'll call you framework. And then we move the shell of the algorithm, now called that basically the template method, and the definition of all standard steps to a new base class. We define a placeholder or hook method in the base class for each step that requires many different implementations. This method can host a default implementations or it can be decided as an abstract. And then we invoke the hook methods from the template method. Each of the existing classes declares an is-a relationship to the new abstract base class. We remove from the existing classes all the implementation details that have been moved to the base class. The only details that will remain in the existing class will be the implementation details special to each derived class. Thank you very much for watching what template methods patterns are.